go. Okay, so we have confirmation that we are recording or streaming. So we'll go to the shared folder. You have access to this already from day one. And inside the share folder, okay, I've opened it several times because of the other class too. So let me close the other ones. So inside the share folder, you will find, oh, this is not the right class. Oh, I think I just closed the one that I wanted to keep. There we go. All right, so inside the share folder, it's still the wrong class. Maybe open the on the other side.
You were in Canvas for cisp310.
Huh?
You were in Canvas for
Oh,
cisp310.
okay. Thank you. Duh. I may become just become the poster child of the absent-minded professor. When you look up that word in Urban Dictionary, you will see my face, right? All right, so once again, we have a share folder. This time is the right one. Okay, there we go. And inside there is an old X1, which is old exam 1. So when you go into that folder, you can get into the folder just fine, okay? You just cannot change any document over there. The document we're gonna go over is this one, 1193-X1-02. This is the exam 1 from last semester. It is the most recent exam 1 in the history of me teaching cisp310. So instead of just opening this, I'm going to download it, and then I can use Zernal to mark it up. So let's see, we want to download. There we go. It's already downloaded once, so it's going to complain, and we'll go ahead and download it again. Replace. There we go. And then I can open Zernal to look at the document and also to mark it up as if I'm answering the questions. Great little program, open sourced. And it opens it somewhere else. There we go. There. Okay, just a quick reminder of no food, no drink in the classroom.
That was just for computers.
Just plain water in the classroom, but no food. But you can drink plain water. Okay, so there we go. Oh, actually, I need to open the document that I just downloaded. Okay. And it is 1193. Okay, maybe just go there. Downloads, there we go. And anime is not going to be very helpful in this case. Although there are certain animes that are computer science related, like Summer Wars, is one. There are a few good ones. The funny thing is, a lot of stuff in sci-fi, in anime sci-fi, is already reality. That's just it's just amazing. What I don't understand is, why in Japanese anime, is still really kind of stuck with the idea of there is a pilot inside a robot. Dead center too. I think that concept, as much as the Japanese can think of, other, sci-fi concepts, like, the concepts in Ghost in the Shell, where, the question, is the soul is still there when you gradually replace a person entirely by artificial tissues, and that includes the brain. So even though they have great, animes like that, you still have, Gundam movies or Gundam, shows where the pilot is actually inside the robot. which means your robot now cannot do all the high G turns and whatnot because the person inside cannot handle it.
It's probably just like media anywhere else. Some are
Huh?
actually, it's probably just like media anywhere else. Some ask big, deep questions, and some are just like franchise cash grabs.
Yep, that's true. Yep, I I totally believe that. So I have my own idea. On another day we can talk about it of how battles in outer space is going to be like, and how that is actually going to change forever. How we look at AI, but that's for another day.
Let's do that instead of the final.
Huh?
Let's do that instead of the final.
Instead of the final, we'll use assembly language to program the outer space combat drone. All right, so this is the part where we start first. Obviously, the date is going to be not the same. The date for us is next Wednesday, so 7 days from today. The time is where the lecture is, so we do not spill over to lab time. Okay, so once again, there will be no spilling over to lab time. The test itself is 80 minutes long, just as long as the lecture itself. Location is this room, so the first three items are pretty easy. Fourth item says you can bring anything that is either printed or handwritten prior to the exam, as long as it is not electronic. Okay, if it's on paper, you can do it. Is that okay? There's no limitation in terms of how much you can bring. I know in some other classes you have a limitation of like 1 or 2 pages. In this class, I do not put a limitation of how much you can bring. You can work with somebody else to come up with that material. Okay, the whole class, for all I know, can be working on one set of cheat sheet, so to speak, together. I don't really care. Okay, so that part is fine. But it is important to remember that each person in class is responsible for his or her own material during the test. So if someone forgets to bring that material, there won't be any sharing of that material once the test starts. Okay. So if one person says, "Okay, I forgot to bring my stuff," and the other person says, "I probably won't need this for the exam," you can have it. That is okay, but that is a one-time permanent transfer of property. Okay, there won't be any sharing of material during the test. So is that okay so far? Okay. All right. So moving on to the individual assessment part, all this is really saying is the score of a particular exam, which I will, report in Canvas, should only reflect the performance or competency of that particular student and no one else. It also has to be based on the assumption that we are observing all the applicable rules using only the amount of time that is allowed. If somebody has a note from DSPS to have additional or different accommodation, I can do that, okay? Not a problem. But if without that piece of paper from DSPS, there's nothing I can do to help people accommodate any differently. This is the first semester that I have to make it explicit that I won't allow any headphones during or any use of headphones during the exam. Okay, before I can kind of understand that some people can want to listen to music, so that they can drown out, all the additional noises around them. But from this semester on, I would not allow that. Okay, so anyone who thinks, okay, but I need special accommodation because I get easily distracted by noise or other things that's going on in the class, they will need to go to the DSPS people and ask for accommodation there. Are we good so far with all of these items? Okay. So once again, no sharing of material during the exam except for maybe an eraser or blank paper. Okay, so those would be okay. Do not discuss the questions with students who may not have taken the exam. Yes.
Sorry, jumping back to the notes. So you're saying in the next part of that sentence, you allow notes for all the exams except the final one?
Which one? Which part?
Open material printed or handwritten prior to the exam with the exception of the final exam itself of the same semester.
Oh, this one, okay, this is a leftover, just, the exam itself of the same semester. This is, this is specifically for people who have an excuse, like, they're sick on that day, so they cannot come in with with the exam, the actual exam, because that person got the exam from somebody else. It also includes, time travel or any other means to get a hold of the exam. So I will have to catch all the time lords in this class. So is that okay? Okay. Use additional sheets of paper if necessary. So if you think that you might need some additional, sheets of paper, um, bring your own. Okay. I'm not going to supply additional, paper. So you will have to bring either binder paper, blank paper, graph paper, or whatever. Okay. But you have to supply that, yourself. I will leave some space. As you will see, each question has some space reserved so that you can actually use that space to write your answer. But if you think that, well, but what if I got the answer wrong, the entire answer wrong, I have to cross out the whole thing, then I might need some additional, space to write my answer. Then you want to bring some additional paper with you so that you can write your answer on a different piece of paper. If you do use a separate piece of paper, make sure you write your name on each paper as well as the question number. Because otherwise, if I, for whatever reason, lose track of that piece of paper, it is not with the exam itself, then I have no way to go back and say, oh, this paper belongs to so and so, and this is the answer of question so and so. Okay, so make sure that you write your name and also the question number on the paper if you do need additional paper for the answer. The next item, write legibly. I'm not going to reward points to answers that I cannot interpret when I'm grading it. In other words, let's just say that I saw something, it looks like a 0, okay? And somebody said, but no, it's not a 0. This is actually a 1 after the fact, okay? I cannot, change the score, because somebody told me that I could not read the handwriting correctly. Is that okay? So what that means is you have to write in a legible way. Now, if you write in a very legible way and I am just mean to you and I say, this is clearly a 1, not a 0, okay? But if you did write legibly, you can take it to the dean, you can take it to somebody else and file a grievance and say, okay, look at this. Does this look like a 0 to you or does it look like a 1 to you, right? If you write legibly, you can easily make a case if I am just being mean. Does it make sense? But if somebody is writing, just scribbling, blah, 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 like that, if nobody can interpret whether it is a 0 or 1, then I can make my case and go like, I cannot see what this is. I cannot give you the point. All right? So just spend some extra time to make sure that whatever you're writing is in a legible way. Make your answers as complete as possible. What that means is, show your steps, show your reasoning. Okay? If there is a definition that you're pulling out of the notes that is applicable to answering a particular question, state that. Okay? Copy the definition from my notes. Because everything that you do gives me a potential excuse to give you partial credit. Is that okay? Okay. So the more complete your answer is, the more likely I can give you partial credit, even if the final answer is incorrect. Okay. If I can see that, yep, this person clearly knows that this relates to carry look-ahead adder. Okay. This person clearly knows, what a carry look-ahead adder really is, how we define the carry functions. And this person clearly knows about, how gates, function. But when I look at the diagram, one of the line is not connecting to where it's supposed to go. I go like, well, I would see this as a minor, issue. The person will still get most of the points. Okay. So this is just for your benefit to make sure that you can get as much credit as possible. Next point is all questions have equal weight. That makes it easier for you to decide which one to work on first. Now, you're already in cisp310, which means you have taken many classes already at a college level. So I think most of you know the strategy, but I'm going to repeat that anyway. If all questions have equal weight, then you quickly scan through all the questions and find out which one seems easiest from your perspective. Now, why don't I put the easiest question as the number one and so on? Because what I see as the easiest question may not be what you see as the easiest question. Okay, it's all individual. Okay, within this class, I would assume that there's a variety of what each person, how each person evaluates the easiness of each question. So you have to do your own evaluation, figure out which one you think, oh, this one is easy, I can get this done in the shortest amount of time. Start with that question, okay? And you move your way to more harder and harder questions as you move along. Because if you do it this way and you run out of time, then hopefully you are only running out of time to answer one of the hardest questions, but you got all the easy ones, okay? But if you do it the other way around and you start with just follow the sequencing of the question numbers, then it is possible the first question turns out to be the most difficult for you. Then you might spend a lot of time to answer the first question and end up with no time to answer the other questions. So you won't be getting as much point as you would otherwise be able to get. Does it make sense? Okay. So that brings up to another point is you already know the exam has 80 minutes. If you know how many questions we have in the exam, you kind of know how much time you should spend on average on each question. Keep that in mind, okay? Because one tendency that some people have is they really need to get one question done before they move on to another question. So I'm not saying you should not do that, okay? There are cases or times when that makes sense, but I'm telling you that, when I answer questions, I just look at the time. If I'm running out of time to answer a particular question and there are 4 more after this one, I just go like, okay, this is as far as I would go at this time. If I have additional time left behind at the end of the exam, I'll come back to finish this one. But then I'll move forward to the other questions. Now, there are some reasons for that, because another question may remind you of how to answer an earlier question. That actually can happen, okay? And then the second thing is you might be able to get some easy points with the other questions, okay? So at least you won't be stuck with one question trying to get like the last 20% of one question instead of being able to answer like the 80% of the next question. Does that make sense? Okay. But it's up to you, because some people may feel that if I just kind of stop with this question, it's very difficult for me to come back to continue the answer later on. So you kind of have to make that call with your own judgment to see whether it makes sense for you, to like just kind of pause on the question when you're running out of time and just move on. Yep.
I noticed this exam is 6 questions. Will
Yep.
our exam be 6 questions as well? Or?
It'll be about the same. It depends on the difficulty of each question as well. So since I have not really worked on the questions for this semester, I cannot tell you what number it's going to be. The idea is I want to make sure that if people know how to answer the questions, they're not going to be limited by how much time it takes to write down the answer. So that's kind of my bottom line is, for someone who knows the material, they should be able to get it done with time to spare. Okay, so that's kind of the criterion that I use to evaluate how many questions based on the difficulty level of the questions. But 6 is about the usual that I do. Some questions may cross pages. I try to make sure that does not happen, but you just have to be careful, okay? Make sure that you read the entire question before you answer. And this exam accounts for 20% of your final grade, which means this exam all by itself carries the same weight as all of the labs added together for the entire semester. So it is a significant chunk of your grade from that perspective. All right, so with that, are there any questions about this portion? Yep.
Do you allow scientific calculus?
Yes, I do. Well, thank you for asking. So I forgot to mention that. So yes, I do allow scientific calculators or graphing calculators. I don't think they will be very helpful. If you have to choose between a $1 calculator from the Dollar Tree, versus your TI-84 plus CE, okay, I don't think the TI is going to be that much more helpful. Okay, the only calculation that we need to do, as you already know in this class, are addition, subtraction, multiplication, division. And if you don't trust your 2 to the power of something or 7 to the power of something, the power function. Okay, so a very basic scientific calculator should be able to do everything that you need to do. And if you're good with mental math, you probably do not even need a calculator. But if you feel that, well, but I feel better if I have a calculator, hey, bring it with you. Yep.
For additional paper that we can use for the exam, I know I know we have probably should label the questions if we need to explain our steps on a piece of paper. But what if we were using scratch paper just for basic mathematical computations for each of the questions?
So I do not need to collect scratch paper. If you want to turn that in as well, it's okay, but you kind of have to mark that this is just scratch paper. It does not contain the answer. Yep. But I do not use that for grading purposes. Yep. You can use the question area as scratch paper as well, because if I see how you do your calculation, that tells me whether you in some cases it tells me whether you understand the concept or not. Yep. Okay. All very good questions. Any other questions? All right. If there are no other questions, we'll look at question number 1. So question number 1, this is the actual exam from last semester, so it's not watered down or in any way. In the following space, we're referring to this part here, fill in the blanks for a 6-bit subtraction so that the subtraction yields the indicated T bits and also the indicated D bits. The T bits are the take bits or borrow bits, and then the D bits are the difference bits. Okay, I'm really hoping by now we understand the notation or how I label each row. Okay, and be sure to tell me how you got the values. Okay, now you can just explain for a few cases, because obviously we have some repetition going on here, so you just have to explain the very basic part of that. Okay. Note that a solution may not be unique. So, there may be multiple solutions to this particular question. So certain places it can be a 0 or a 1. Okay. All right. So we look at this and say, all right, how do we work on this? So we look at constraints. Okay. This is one problem-solving method, is to look at constraints, because the constraints will tell you what can and cannot be. Okay, I'm going to use my stylus here because I will pretend that I'm actually answering the questions. So the typical way to look at this is to work out the bits from right to left. Okay, and we work on the bits that we immediately know what the answer is. Okay, so we'll fill in those right away, and then we'll work on the ones that go like, well, this one is a little bit harder. How do we work on that? Okay. So the first thing you need to do is to find out, okay, we are given the T and the D, and the rest are not, is up to us to figure out. Okay. So which one do you want to work on first? The X, the Y, or the Q? The Q's. Okay. So it looks like we have to find how Q, T, and D are related, doesn't it? Right? Okay. So can someone tell me how they are related? It's a definition that we have already used in the notes. Yes?
Exclusive OR.
Exclusive OR. Okay, very good. So we say, DI is QI exclusive OR with TI. So at this point, for this question, you don't have to tell me why that is the case. You just have to mention that D relates to Q and T using exclusive OR. That's all you need to tell me, okay? So you don't have to explain it all the way and say, oh, in subtraction, 1 minus 0 is 1, 0 minus 1 is also 1, but 1 minus 1 is 0, and so on. You don't have to explain all that. You just have to explain this part here. This is already enough for me to figure out all the qubits, doesn't it? Okay? because we can work our way backwards. If the result of exclusive OR is a 1, and one of the things is exclusive ORing is 0, what is the other one? It has to be a 1, right? So to know that, it relies on this thing here. Okay, so if you have Q, T, and D, it's optional. I don't think, in this case, I would need you to give me the truth table, but it is helpful. In other words, the truth table tells me how to look up, for the answer. So let's say we're talking about this, okay? D is 1 and T is 0. D is 1 and T is 0. We are looking at this row here. Is that okay? And that is why I know we can put a 1 here. All right? So without, fully explaining, all the other columns, I just reapply the same technique to all the other columns. So now I can say this one has got to be a 0. This one has got to be a 1. This one has got to be a 0. Is that okay? So the qubits are pretty easy to work with. The XY are a little bit trickier because you can't really just say, oh, we know this Q is a 1, so I can either have 1, 0 here or 0, 1 here. Well, only one works. The other one does not work. The reason is because we have an extra constraint. We have a carry bit here. So once we have a carry bit here, which is T1, okay, if T1 is 1, that means we have to have a borrow from bit 0. Q minus T is not going to give us a borrow, is it? So that borrow has to come from X minus Y. And the only time we have a borrow bit of 1 is when X is 0 and Y is 1. So that leaves me no options but to use 0, 1 for this one here. Now, if you want to make sure that you get partial credit, even if you make a minor mistake, somewhere, you might want to mention that Ti plus 1 is not Xi, Yi, or not Qi, Ti. Because that is how we derive the borrow bit for the next column. All right? Okay, so we move on to the next bit 1. So bit 1 also results in a borrow, but we already accounted for that borrow. That borrow is coming from here. So, and also, this is a 0 here. We cannot have a 0, 1 or 1, 0 here, but we can have 1, 1 or 0, 0. Is that making any sense? Because 1 exclusive for 1 is 0. 0 exclusive or with 0 is also 0. So in this case, I cannot tell which one is supposed to be the case, so I can use either one. Okay, if you say 1, 1, I'll give you full credit. If you say 0, 0, I'll give you full credit. Okay. All right, moving on to the, bit 2. Bit 2 does not yield any borrow to bit 3. How do I know? Because T3 is a 0. If that is a 0, that means this is not giving me a borrow, which is fine, but this is also not giving me a borrow. So if X minus Y is not giving me a borrow, and yet it has a result of 1, that limits that I only have one choice in this case, which is 1 minus 0. Is that okay? Does everybody understand why we cannot have X being 0 and Y being 1? Because that would have yielded a borrow to T3, so that would not be good. Yep.
So T sub 0 is an implicit 0, is that correct?
Yes.
Okay, and then we can essentially use just the definition of the borrow subroutine right there to just kind of backwards.
Yeah, we're basically we're working out these things backwards. Yep, absolutely. Okay, one more column to go and we are all done. So what about X3, Y3? There's no borrow. The result is a 0. Well, when the result is 0, it's pretty easy. Okay, it's either 1, 1 or 0, 0. So in this case, should it be 1, 1 or 0, 0? Hey, yeah, give me either one. So you can use 1, 1 or 0, 0. I will give you full credit for either one. So I'm going to choose 0, 0 here, just because. Yep.
I noticed in the question it says a 6-bit subtraction. Is
Yeah, that's my mistake.
Okay.
Yep, because in one version of this test it was 6-bit from a previous year, so I forgot to change the description. Very good. So is that okay? Does everybody understand, how question 1 was done? So you might notice that this is not a technique that we have done or that I have demonstrated in class prior to today or in any one of the labs. You will be 100% correct about that. But have we talked about the T bits? Have we talked about exclusive OR, the Q bits, and so on? Yes. So I give you all the tools, but you still have to apply problem solving in order to answer the question. Okay? If somebody could not figure out how to apply the knowledge to answer the question, but is able to figure out, well, I'm guessing we need to know the definition of D, I'm guessing we need to use the definition of T, that person will still get partial credit, even if this part is completely blank. Because that person has illustrated that at least that person knows what knowledge is needed to answer this question. Now, whether it's going to be a D or a C is kind of questionable. I cannot determine right away. I'm leaning to a D in that case because it does not really answer the question. But at least some points in that case, partial credit. But this does not mean that people can just quote every definition there is under the sun, hoping that at least one of those will hit the mark. If I see a lot of noise and not enough signal, I will still just give that person a 0. Just to make sure that people don't quote every single definition under the sun. In fact, I can even imagine, I'll address that. I can even imagine if I was a person like that to really test the limit of the professor, I'll put all the definitions ever mentioned up to this point on a separate sheet of paper, staple that sheet of paper as part of my answer, and with every single question I say, see attachment blah. Just to shotgun everything, right? So I would basically make sure that does not get any points. Yes?
What if you don't write any of the definitions down?
If you do not write any of the definitions down, then I will look at the answer. But then you have no safety net to get partial credit if your answer is actually wrong for some reason. I mean, if it's not all wrong, I will still give you partial credit. But if you make some big mistakes here, then you may not be getting as many points as you would otherwise get if you had mentioned the definitions. Right, so this is question 1. Let's move on to question 2. Question 2 is, well, let's see. I think the biggest problem with question 2 and 3 is to understand the question itself. Okay, so let's see if we understand it. Convert the following number, which is 202.11, with a 3 as a subscript, into a base 10 mixed fraction, step by step. Okay, I think step by step we all know what that means. Okay, just show me the derivation. Base 10, I think we understand what base 10 is. It's just decimal. Mixed fraction, I give you an example of a mixed fraction which has an integer followed by a fraction. Is that okay? So now the question is, what is this number? 202.11. What is that 3 doing? Yeah, go ahead. It's base 3, thank you. But since you raised your hand, I particularly want your answer. So it is base 3. So now we have a number that is in base 3, and I want to convert it into a base 10 mixed fraction. Okay, so how do we do this step by step? Well, we use an equation or a sigma notation that we have talked about many times in this class. So the sigma notation goes like this, okay? V of some kind of number, okay? We'll call this x here, equals to the sigma of I. In this case, I goes from -2 to +2, okay? x subscript I, which is referring to digit I. And because we're using base 3, so we multiply xi to 3 to the power of I. Do you vaguely remember something like that? I think the first time we looked at this was when we talked about base conversion. Yes? Okay. So this is how we figure out the value represented by a particular number x. X doesn't have to be base 2 or any particular base, because whatever base it is going to be the base of the power notation. Is that okay? So we just plug in all the numbers, right? So in this case, we just plug it in and we say the value 202.11 in base 3. Now, if I want to really kind of go slow, this is how I would do it. 200 in base 3 plus 2 in base 3 plus 0.1 in base 3 plus 0.01 in base 3. So I separate all the digits out first. Then I say there are 2 of the 100s in base 3. There are 2 of the 1s in base 3. There's 1 of the 0.1 in base 3. And there's 1 of the 0.01 in base 3. Okay, I'll move this paren over here. So you can see that the first line is just separating the digits. The second line is to separate each digit into a quantity times 1 followed by some numbers of zeros, or point and then at some point get to the 0. Okay, so at this point we do the actual conversion, because at this point we basically say, oh, this is 2 times 3 to the power of 2. Because when you look at 100 in a particular base, it is that base raised to the power of the number of zeros, which is 2 in this case. This one is 2 times 3 to the power of 0. I mean, only if you want to kind of go through that. The fractions are the difficult ones, okay? Because most people have problem with this part. This is 1 times. What do we use? We know that this has to be a power of 3, but what power of 3 are we talking about? -1. Very good. So that makes the next one kind of easy too. It's just 3 to the power of -2. So now we convert everything into a base 10 representation. 3 to the power of 2 is 9. Twice of that is 18. This is just 2. This is 1/3. And this is 1/9. And if you add them all together, you have 20 and 9 as the final answer. Is that okay? So with this one, it is a little bit tricky when it comes to grading, because what I found from last semester was a lot of people can handle the part to the left of the decimal point, but a lot of people do not know how to handle the part to the right of the decimal point. So obviously, if someone cannot answer this part, is not going to get full score. So the question is that a B answer or is that a C answer? I would put it into a C answer instead of a B answer. The reason why that is the case is because it illustrates that that person or that answer is showing me the person did not understand the concept entirely. So it is a conceptual issue. It is not an issue of, oh, I just made a mistake. Okay, I did my arithmetic wrong. Arithmetic wrong is what would get a person from an A to a B, but a conceptual problem would bump to a C. So that means when you're studying, you have to understand the concepts, okay? It is not about the procedures or the process of doing something. It is about the understanding of the concept and the ability to apply the concepts to solve a problem. So in this case, it is all about the concept of what is a number? What is each digit representing in a number? So are we good with number 2? Shall we move on to number 3? Okay, I see some people still copying, so I'm going to give you guys a little bit more time. So are we good? Yes? Are we okay? All right. Okay, so moving on to question number 3, which is the reverse of the other question. So this one starts with a mixed fraction, which is 146 and 41 divided by 49. This is in base 10, okay? Clearly stated in base 10. And I want to convert it into a base 7 number using decimal notation. So it's exactly the opposite, right? So what do we do with this one? Well, we are really trying to express the quantity that we know of as 146 and 41 divided by 49 into quantities times some powers of 7. We basically want to boil this down to, oh, we got this many of 7 to the power of 2, this many 7 to the power of 1, this many 7 to the power of 0, this many 7 to the power of -1, -2 potentially, okay? That's what we want to do. So what is the process to do it? Well, since I'm really bad with arithmetics, if I forget to bring my calculator, this is what I'm going to do. So I would say 146 with 41 over 49. I would first take care of the larger powers first. So in this case, I can see that we don't have any 7 to the power of 3. Okay, that's pretty big because we are talking about 49 times 7. So that's like 300 something, right? And this number is 140 something. I know we don't have any 7 to the power of 3. Is that okay? So I don't need a calculator to find that out because I know 7 squared is 49, which is pretty close to 50. 50 times 7 is 350 already. Okay, and this is like only less than 1/2 of that. So I know that we do not have 7 cubed. So that means 7 squared is probably as high of a power as I need. So now I need to figure out, okay, but how many 49s do we have in 146? Well, okay, you can either do it by hand, okay, do it on the side, okay, and do a 146 divided by 49, which is not very helpful, right? This is why we don't like base 10. Because in order to do division, you have to be very good at multiplication first. Like in this case. Well, there are 0.49 in 1. There are 0.49 in 14, right? So long division doesn't help at all. You really just have to kind of guesstimate. It sounds like it could be 3, it can be 2, right? You just have to, in your head, carry out the multiplication. 3 times 49 ends up with a 7. Okay? And so you can do it the other way around, which is 3 times 50 minus 3. It's the same thing. So that would give you 147. Oh, that's too much. So that means we only have 2 49s in 146. Is that making any sense? So even without a calculator, I can kind of use mental math to help me in this case. So I would put a 2 times 49 here, because 49 is a power of 2, power of 7. The key is to make use of units that are powers of 7 in this case. Okay, so now this is where I'm going to potentially lose points because I'm very, very bad with arithmetics. So I'm going to write on the side and say we are subtracting 98 from it because 2 times 49 is 98. So there's an 8 here with a borrow. 4 minus 9 is a 5 with a borrow. And then 5 minus 1 is 48. Yep, that makes sense, okay? Okay, so after the subtraction, if I end up with a value that is at least 49, I have made a mistake in my division. Okay, so this is kind of like a sanity check to make sure that I did not make a mistake in my division, is to make sure that after the subtraction, I do not have at least 49 left. Okay, okay, so looks like I got that part. So now I write down this 48, and then the fractional part is still the same, which is 41 divided by 49. So the next step is, okay, let's rewrite this one. So I can kind of do this on the fly. as I try to figure out how many 7s we have in 49. We know pretty much for sure that we don't have 7 7s in 48. Because otherwise we would have bumped this up from 2 to 3. So 6 it is, right? 6 times 7 is 42, which is as close as we can get to 48. So we have 6 7s, okay? So I write this down, 6 times 7, 6 times 7, and then plus whatever is left, okay? So 6 times 7 is 42, and 48 minus 42 is 6. So this one I can do it without actually writing anything down or scratch work on this other side. Is that okay so far? So with each step, all I am doing is to boil things down to how much of a power of 7. So in this case, this is 7 to the power of 1, which is basically 1 0 in base 7. Is that okay? Does everybody understand why I changed from 7 to 1 0 in base 7? Because the only way for you to represent the quantity of 7 in base 7 is 1 0. Okay? All right, so now we're down to the 6. How many powers of 7 do we need in 6? But now we're down to 7 to the power of 0. Okay, that's an easy one. So we say 6 times 1 in base 7, and then we have 41 divided by 49 left. Okay. And if you want to kind of do the conversion and combine all the digits together at the same time, feel free. So we can say it is 266 in base 7 plus, okay, now we look at 41. What is the next power of 7 at this point? We have done 7 to the power of 2, 7 to the power of 1, 7 to the power of 0. So the next one down is 7 to the power of -1. Okay, 7 to the power of -1 is 1 divided by 7, or 1 over 7, right? So how many 1 over 7s do we have in 41 divided by 49? 5 of them, okay, very good. So we say 5 times 7 to the power of -1. And then what is the leftover in that case? 41 minus 35 is 6, okay? So now we combine this part, becomes 266.5 plus, all right, so we look at 6 divided by 49. I think we are done, because 7 to the power of -2 is 1 over 49, and we have 6 of them, right? So we have 6 of 7 to the power of -2. So the next line, or to save space, we will put it on the same line, is 266.56 in base 7.
So it says step by step. If we didn't do these steps together and we did it by another means, would that be okay?
You still need to show me that you understand what the process. In other words, what does each digit mean in the conversion? So somewhere, okay, in your derivation, you have to tell me that we have 2 times 7 to the power of 2. Now, whether you skip all the way to this representation, or you start with this representation, or you say 2 times 7 to the power of 2, that's up to you.
Show like in a table.
But if you show it on a table, it does not tell me that it is a summation of those quantities times power of 7.
Okay.
Yep. I mean, writing this out is not going to take you that much time, so you might not want to risk losing your partial credit. Yep. All right. Any other questions about this? Okay. Now, remember I said I'm really particularly bad with arithmetics, and I easily mess up subtraction and whatnot. So if I do mess up a subtraction, but I show all the steps, I would still get a B grade out of the whole thing, because I show all the steps. I show that I understand the process. It's just that I make a mistake in the process. On the other hand, if I skip everything because I did everything on a different sheet of paper and I do not bother to copy here, and the answer is wrong, I mean, from the professor's perspective, what am I going to do with that? Am I supposed to give partial credit? How do I know whether the person understands the process to get here when the answer itself is wrong? So the point is, give me all the steps in between. Show me that you know how to do it. Show me the steps that you use to finish the calculation. Okay? All right, question number 4. I like this question. Question number 4 is kind of long, so one of the things is you have to know what it is asking you to do, what is given and what is asking you to do. So we have to read the question carefully. In this question, we are considering a borrow look-ahead subtractor. Okay, that's important because right away you know which part of the notes is relevant. Okay, we are talking about subtraction, and to be more specific, we are talking about the borrow look-ahead mechanism, not borrow ripple mechanism. Okay, so that tells you which section of the notes is relevant in this case. In which x is the minuend and y is the subtrahend. That's the usual notation, okay? Because the way I describe a subtraction is x minus y usually, okay? I think I have not used the other way around at all in this class. So x being the minuend and y being the subtrahend is just kind of extra information to make sure that we know which way we are subtracting. In particular, we are examining T3, and I give you the entire T3. I tell you what it is. Okay. Of course, I made a mistake here because that really should be T0 and not K0, but the structure is the same. And I want you to focus on the conjunction of U. U is just a name for the conjunction. It is P2, P1, G0, which is one part of how we calculate T3. Is that okay? So I'll just give that term a name U. Okay. We know that u equals to 1. In other words, it is given to you that u is 1. Okay? And we also are given, okay? Don't ask me why, but you're given these facts, okay? You're also given the conjunction y2 not y1 y0 is also 1. Okay? So those are all given to you. Use the following space to figure out a possible combinations for x0, x1 and x2. x0, x1, x2 are individual digits of x, which is a binary number. So how do we figure this out? So once again, we think about constraints. Okay, what are the constraints already placed because of the question itself? What is given to you? Okay, so what definitions can we pull from the notes that might be helpful in this case? What do you think? We need to figure out x and given y, but we are also given something about p's and the g's. Okay, so what definition do you think we need? Yes. Huh? The definitions of p and g in the context of adder or subtractor? Subtractor. Very good, because they are different. Okay, so the first thing I would do is I will write down, I might need to use this. G of I is not xi, yi. P of I is not xi or yi. Okay, that's coming straight out of the notes. Okay, you do not have to understand how we come to this particular definition, which is like long, huge, derivation. So you don't need to do that. You just say, well, in text note, this is already done. Okay, that's the definition for subtraction. Then what else do we know? Well, conjunctions are very, very useful, because if you know a particular conjunction is a 1, that means all the components of the conjunction have to be 1s as well. Okay, so then we look at P2. Okay, so then you say P2, P1, G0 is a 1. This, okay, now you don't have to use the implication symbol. You can say because of this, that is the case, or just mention the 2 on the same line. Okay, But because of this, we know that each individual part, P2 is a 1, we know that P1 is a 1, we also know G0 is a 1. Is that okay? Does that make sense to you? Because in order for a conjunction to be true, every single component of the conjunction has to be true. There's no other way to make a conjunction true. Is that okay? Now, for those of you who want to point out and go like, but Tech, your math is not as strict as it possibly can be, fine. Make it if and only if. Okay, I'm just nitpicking here. Don't worry if you forget about the other arrow. Okay, but in the math class, that would become important. All right. So the other thing we can also do is to look at the y expression. Y2 not y1, y0 is a 1, but that can only be the case if I already know that y2 is a 1, y1 is a 0, and y0 is a 1. Using the same line of reasoning, right? Because there are 3 components to this conjunction. Y2 is one component, not y1 is one component, y0 is the 3rd component. In order for the entire conjunction to be true, they all have to be true. So that tells me that individually, we know all the y bits as a result. Okay, y0 is a 1, y1 is a 0, y2 is a 1. So now it's time to figure out the x bits, right? All right. So we look at the x bits and we'll work with x0 first. So we have to look at G0 and ask, what exactly is G0? Oh, wait, I know how the G terms are defined. So G0 is really just not x0, y0. Is that okay? That's really just applying, this definition of G down here. We good? Oh, that's easy because now y0 has to be a 1, but we also know that x0 is a 0 in this case. So that tells me that x0 is a 0. So we got one of the 3 bits already. Let's try to work on the other 2. P1 is defined to be not x1 or y1. Okay? And that is also a 1. We know that y1 is a 0, right? So let's think about all the pieces that we know at this point. We know y1 is a 0, and that in return comes from the conjunction of all the y bits is a 1. Okay, not all the bits, but y2, not y1, not y0 is a 1. So we know y1 is a 0. So we know this is 0. Does that restrict what x1 has to be?
No.
Yes. Because you have an or false here, right? Or false doesn't do a single thing because true or false is true, false or false is also true. So or false is like plus 0 in arithmetic. It doesn't do a single thing. So that means not x1 is true. If not x1 is true, that means x1 is false. Very good. So this means x1 is false. We are now going to work with P1, or P2, excuse me. So P2 is not x2 or y2. What is y2? Y2 is a 1 already. So that means, x2 can be either 1. Okay? It is inconclusive. x2 can be 1 or 0. Now, what if somebody tells me that x is 1? Partial credit. Because the correct answer is x2 can be either. Okay, so if someone tells me x is 1, that person is not telling me that it can be the other. Yep.
Technically, it says to reason out a possible combination, so that is a possible combination.
Yeah, I suppose. I guess because if I say to reason out a possible combination, then I will take just one of them. If you give me one that works, it has to count. to get all the points. Okay, that's correct. Very good. I mean, I really am glad that you guys are reading the questions, to that detail, really, because if you're not voting yet, you'll be a voting, member of society for a long time, and we need people who read carefully and question everything. All right, question number 5 of 6. In this question, step by step, derive the base 10 signed value represented by the 6-bit binary number of 010011 in base 2. Okay. So to answer this question, there are 2 ways to do it. The first way to do it is to say, oh, we see that the sign bit is a 0, so we only have to add up the powers of 2 corresponding to the 1s. And then it becomes 1 plus 2 plus, what is that? 4, 8, 16. 1 plus 2 plus 16, which is 19. So that's one way to answer the question. But to use that particular question, you have to say that because the sign bit is a 0. Okay? Because if the sign bit is a 1, then you have to use 2's complement to find out how negative the number is. Okay? Sorry?
We could just, if you're doing the same step by step derivative, you just have negative 2 to the power.
Yes, but or we can use the signed number value interpretation equation. Okay, so let me see if you guys still remember this one. V of x, once again, is a sigma notation. So we are talking about n bits this time. Okay, so for n bit numbers, I goes from 0 to n minus 2, x of n, which is the digit n of x, times 2 to the power of n. And then after this whole thing, we subtract x subscript n minus 1 times 2 to the power of negative 1, n minus 1. Do you remember this? This equation is pulled out of binary comparison. Okay? It is how we interpret the bits of a signed integer, which is represented as a base 2 number. Is that okay? This is universal. Okay? This equation does not depend on whether the number has a 1 or a 0 as a sign bit, because the sign bit is x subscript n minus 1. If it's a 0, that means we don't have to subtract anything. If it is a 1, then we have to subtract 2 to the power of n minus 1. Yep.
Just want to make sure I got the formula wrong, but for the first, like, xn 2 to the power n, I have xi.
Oh, xi, you're correct. It is the variable being iterated here. Yep, you're correct. There we go. Sorry about that. So in that case, you can use one single equation regardless of whether the sign bit is a 1 or a 0. So if you expand this out, then you have 1 plus 2 plus nothing plus 16 minus nothing. You still end up with a 19. But the nice thing about using this particular equation is if I give you a binary number where the most significant digit is a 1, it's the same equation. There's no need to make a special case and say that, well, because the most significant bit is a 0, this is the case. Because the most significant bit is a 1, this is the other case. This is like one single equation that works for both cases. So I kind of like this solution better. So are we okay so far? Okay. Moving on to the last question, which is also a question that I like a lot. All right, so first of all, read the question first, figure out what it's asking. In this question, you're given the minuend x as the following 6-bit binary number, 000011 in base 2. Step by step, find the subtrahend y such that the binary subtraction x minus y barely sets the overflow flag. Barely in double quotes means a value that is one off from the one that you choose would result in a subtraction such that the overflow flag is not set. Okay, so I have a lot of questions from from that semester, as well as from yesterday, about what do you mean by barely? Okay, barely means barely. It means it is the first value that will set the overflow flag. Is that okay? The value before this one would not set the overflow flag, but this value, the value that you have chosen, would set the overflow flag. There are two ways to approach this. Okay, I'm going to go with the more bitwise operation oriented method first. Okay, and then I might go talk about the other method, which seems a lot simpler, but it is actually not as simple conceptually. So let's start with the bitwise thing. Okay, so what we'll do is we're going to write out this entire subtraction. So we say x is 0, 0, 0, 0, 1, 1 in base 2. We don't know what y is. Okay, and as a result, we do not yet know what q is, and we do not yet know what t is. Okay, but we do want overflow, right? All right, so now the question is, given this many stuff that we do not know, and we want overflow, what definition do you think I need? The question answers itself. Yes, go ahead.
The range for how many what values.
You can use that, okay? But if I use this particular method, which is basically reversing the entire subtraction, and I did mention that question answers itself, we need the definition of the overflow flag, okay? So you can look up, in I think it's binary comparison, okay? The overflow flag is defined as the sign bit of the minuend and the negation of the sign bit of the subtrahend and the negation of the sign bit of the difference, or the negation of the sign bit of the minuend and the sign bit of the subtrahend non-negated, and the sign bit of the difference non-negated. I believe this particular notation was used in the lab, but the concept was the same. I think in the notes, I just used MSD instead of using the subscript S as the sign bit of those components, but it's the same idea, okay? So we are looking at the most significant bits of, in this case, x, y, and the difference, which is the last row, okay? And we do want to have a overflow because we're looking for the first value that will give us an overflow. What do we do next? Well, if overflow is a 1, which means this is a 1, there are two ways to make overflow 1, aren't there? One way is to make the conjunction to the left a 1. The other way is to make the conjunction to the right a 1. These are the only two ways to do it. But one of these two ways is not possible anymore, is it? Okay, which one is not possible anymore, the left or the right? The left is not possible anymore because this one can only be a 1 if the minuend has a sign bit of 1. But we are given a sign bit of 0 for the minuend. So what is that leaving us with? The 1 to the right-hand side. But if the 1 to the right-hand side is giving us a 1, what do you think is telling us about the sign bit of the subtrahend and the sign bit of the difference? They both need to be 1s. Very good. So that is how we start to fill this in. We put this one here, and we put this one here. You look at this and go like, it doesn't seem like it's helping, right? Trust me, it is. It's a start, okay? But it's helping tremendously. Because once you know the x and the y, how do you get to the q? Exclusive OR. So it might be helpful from the perspective of reminding you this is useful, and also to show that you know what part of the notes is related to this question. Okay, so it will give you partial credit if you leave the rest. If this is all you turn in, you will get partial credit just because you quote that. and this. Is that okay? And that is why it is important to make your answer as complete as possible. To basically, as you start to connect the pieces, even if you cannot make complete connections yet and know how to apply those pieces, if you just write those pieces down, as long as it is relevant and it is not noisy, as in you quote every single definition there is, I will give you partial credit. Yes?
Are we unable to get full credit if we don't include them?
That is correct as well. So I need to know your reasoning. So if you don't explain your reasoning or it is not clear from your answer how you reason this out, then you won't be able to get full credit either. Now, if you run out of time, okay, then you kind of have to evaluate whether to give me as much explanation as possible or just to sprinkle some explanation. Hopefully that will give you some points because you don't want to run out of time entirely so that you don't give me the entire answer. So you can always go back to backfill the reasoning. Okay, so we know what Q is. So that means, I can now figure out what this bit is, right? Because 0 exclusive or 1 is 1. Yes? Would that help me with the T bit? In other words, can I now backfill this particular bit? Yes, because we also know the relationship between the difference and the QT bits. The difference bit is the Q bit exclusive OR with the T bit. So that means I have no choice but to put a 0 here. So how do we work our way backwards? Well, let's see. What do you think? Do you think we can go back, one column and figure out the entire column itself? I think so. This is Ti plus 1. Ti plus 1 has a relationship to the xy of the previous column as well as the qt of the previous column. There's no borrow. Well, if there's no borrow, what do we know about this one? Can it be a 1? Cannot be a 1. It can only be a 0. Okay? Well, if that is also a 0, that means this part here has to be a 0, right? Because the Q is the exclusive OR of the X and the Y. What about this one here? Do we have any clue to lock down that particular value? Or can it be both 0 or 1? We can lock it down. The reason why we can lock it down is if this was a 1, we would have a borrow here. But we did not. So that means this has to be a 0 too. Is that okay? Do you see, this constraint-based reasoning is really helpful, to kind of work our ways backwards? Okay? Now, constraint-based reasoning is also what you can use. Now, this is out of the scope of this class, but this is also the kind of technique that you can use when you're debugging a program. Given what you can observe when the program crashes or when it stops on a breakpoint and you first notice, hey, my program is not doing what it's supposed to, the values in the variables at that point of the execution is giving you the constraints that you can use to reason your way backwards to try to figure out what went wrong with your program to get to that point. Okay? But I'm not going to spend too much time on that particular topic because I want to finish this one. Okay, so we now want to work backwards to the other, the previous column. It's going to be the same reasoning, right? Because we have no borrow here. This has to be a 0. So that means this subtraction cannot give me a borrow. If it starts with a 0, this has to be a 0 in order not to give me a borrow. So I don't have a choice. If that is the case, the Q bit has to be a 0. And because the borrow here is a 0, I do not have a choice but to put a 0 here. So that means, I can apply the same reasoning here. The previous column has exactly the same pattern. So we also know that we can backfill this whole column with zeros. Now we have a choice. Because even though we have no borrow here, but since this is a 1, well, 1 minus 1 has no borrow. 1 minus 0 also has no borrow. So now you do have a choice. So now in your mind, what you need to ask is, if I put a 0 here, and what am I making y? Am I making y further away from 0, or am I making y closer to 0? We are looking for the boundary case. We are looking for the first value to cause an overflow, right? We want it to be closer to 0, okay? And should this be a 1 to make it closer to a 0, or should it be a 0 to make it closer to a 0? It should be a 1 to make it closer to a 0. All you have to do is to think about -1. How is -1 represented in binary?
You block that.
Sure.
My class has a field trip. We don't need to room.
Oh, thank you. Okay. So in this case, it is actually a 1. Because the binary representation of -1 as a binary, as a signed number, are all 1s. So that gives you a clue. Now you're more than welcome to make a small number wheel to bring with you, because the small number wheel, like only using like 3 or 4 bits of number, will give you a sense of, the more zeros I have, the further away we are from 0, because it will give you that sense. So just a 8 click pi would be helpful as on the sheet of paper. Okay, so we want this to be a 1. So 1 minus 1 is a 0. This one has to be a 0 because we have no borrow here. So now we can do the same thing over here. And we have our, okay, I'm missing 1 digit somewhere, didn't I? 1, 2, 3, 4, 5, 6. Nope, I'm not missing anything. Okay, very good. So the question is asking, find the subtrahend y, blah, blah, blah. It didn't say, in binary or in decimal. So if I do not specifically say find the decimal representation of y, you just circle this and you're done. Is that okay? But those of you who are curious of, but what is it actually representing? Let's try to figure out that, okay? It relates to the previous question of, if I give you a binary bit pattern and I know it is supposed to be interpreted signed, what value is it representing, okay? So we basically look at this and say it is 1 plus 2, okay, plus 0 plus 0 plus 0, right? Minus what? What are we subtracting? 32, okay? So it's 3 minus 32, which is -29. Does it make sense? This is 3. 3 minus -29 is 32. Is 32 a value that you can represent when you're only given 6 bits and you're supposed to use signed interpretation? The answer is no, but how do we know it is a no? Because we talked about how to specify, how to figure out the range of values that you can represent given a certain number of bits. And 32 is out of that range when you're only given 6 bits. So all of that stuff is interrelated, okay? So I'm going to stop here as far as this lecture is concerned. The other way to do this is to do the reverse. You start with the most negative value, and then you subtract x from it, and you get a pattern like that. So that's the easier way to do this. Is that okay? All right. So I'm not giving you a new lab activity today because we did not go over any new material, so therefore no new lab. So if you're already done with all the labs, you're all caught up with all the labs, there's nothing you need to do at the lab. You can not show up at the lab. If you are still working on the lab that was assigned on Monday, then you can go to the lab and I can take a look if you want me to. So either way, we have no new lab activity today.